We have in chemistry the third chapter, acids, bases, and salts. This is the most important chapter in chemistry because whatever you learn in chemistry is connected with this acids, bases, and salts. I gave you a brief introduction of acids in the last class. Today, we will proceed further with acids especially. Today's class will be specifically on acids. So let us study what is an acid first. An acid is defined as a substance, as a compound which contains hydrogen ions that dissolved in solution. Acid is defined as a, don't write down now, try to follow. Acid is defined as a compound that gives hydrogen ions, H plus ions, when dissolved in water. When dissolved in water, it gives hydrogen ions, and that is the only positive ion. Hydrogen ion as the only positive ion when dissolved in water. And this hydrogen ion is replaceable. A metal can replace this hydrogen ion from acid. So acids are number one, acids are compounds. This is the first thing. Acids are compounds. And they contain one or more, 1, 2, 3, or even 4. One or more hydrogen ions. One or more hydrogen ions which can be replaced. This can be replaced by metals. So, second definition. First thing is acid is a compound. Acid is a compound which contains replaceable hydrogen ions. Replaceable hydrogen ions. And when dissolved in water, they produce H3O ions. H3O plus ion. Earlier I have taught you already. When H plus ion dissolves in water, adds to water, you get H3O ions. H3O ions are obtained by H plus ion dissolving in water. When you learned about elements, you must have learned about atoms and molecules. Atoms and molecules. You know, an atom is the smallest part of an element which can take part in a chemical reaction. That's the definition we give. Atom is the smallest part of an element that can take part in a chemical reaction. And a molecule is the smallest part of an element which can exist freely in nature. A molecule exists freely in nature. An atom may not exist freely in nature, but a molecule exists freely in nature. That's the reason we said hydrogen atom cannot exist. An atom of hydrogen cannot exist freely. It will immediately combine with another atom of hydrogen and a shared molecule H2 is formed. A single atom of hydrogen has no free existence. It will combine with another atom of hydrogen, and what will happen is actually a covalent bond is formed between two hydrogen atoms. A covalent bond is formed. Then this molecule is called H2, and that has got free existence. It can exist freely. It can exist freely in nature. In the same way, why I told you this is, I have an action gland here. The same way, here, just as one hydrogen atom cannot exist freely in nature, it combines with another hydrogen atom by sharing electrons and forms H2, which can exist freely in nature. This has no free existence. Atoms. This has free existence. So also, H ion, H ion in the acid has no free existence. H ion in the acid has no free existence. When it combines with another molecule of water, forms H3O ion, it has free existence. So we normally define acid as a substance, as a compound which contains hydronium ion. This is called hydronium ion. So acid is a compound that contains hydronium ions when dissolved in water. Acid is a compound which produces hydronium ions when dissolved in water. This is the correct definition of acid. But this hydronium ion, it is not very easy to continue with that very long. So people even now define it as hydrogen ion. But you should know it is not hydrogen ion which is responsible for the acid character, but the hydronium ion is C. So I have told you two things now. Number one, an acid. An acid is a compound which contains replaceable hydrogen ions in solution. Since hydrogen ions have no free existence, it combines with another molecule of water and forms hydronium ion, which I told you is H3O plus. So, actual definition of acid. In actual definition of acid, we should say hydronium ion and not hydrogen ion. But in practice, we will be using H plus hydrogen ion. The acids are substances or compounds which contain, when dissolved in water, hydronium ions in solution as the only positively charged ion. Only positively charged ion. Are you able to get it, children? Acids are compounds containing hydronium ions when which are the only positively charged ions in acid. Now, if you can take down the definition, you can note down the definition. Please note down now. Acids are compounds. Acids are compounds, COMPOUNDS, containing one or more replaceable spelling REPLACEABLE, replaceable hydrogen ions when dissolved in water. They are the only positive ions in acid. They are the only positive ions in acid. Since hydrogen ions H plus do not have free existence, they combine with molecules of water. H2O to form hydronium ions. Now, that's the definition of acid. I hope you understand the definition of acid. Now, acids are of different types. Acids are of different types. depending upon their origin, where from they come. Depending upon where from they come, acids are of different types. There are one is organic in nature and the other is inorganic in nature. Acids are organic or inorganic in nature. Organic acids are of plant origin. Organic acids are of plant origin, mostly connected with plants here. And inorganic acids are mineral acids. They are from minerals. Mineral acids. So depending upon the origin of acid, acids can be divided into two types. One is organic acids and the other is inorganic acids. Inorganic acids are the common acids you have heard about: hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. These are all inorganic acids. Hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. These are all inorganic or mineral acids. Organic acids are, you can say, CH3COOH, that is, this is otherwise called acetic acid. CH3COOH is called acetic acid. Nowadays it is another name, ethanoic acid. Ethanoic acid or acetic acid, that is CH3COOH. Another is HCOOH. This is called formic acid. Formic acid. It is also called methanoic acid. We can learn later. Formic acid is better now. HCOOH. So acetic acid, formic acid, acids. The other day I told you about acids which come from organic sources, citric acid, stearic acid, many other acids are there. They have all organic origin. Organic origin. So from the origin of acids, we can divide acids into two classes. One is organic acid and the inorganic acid. Organic acids are plant origin, acetic acid, formic acid, etc. are organic acids. Whereas hydrochloric acid, sulfuric acid, nitric acid, etc. are mineral acids. Okay, I hope you understand. Acids are different types according to the source from which they come, origin or source from which they come. Those are of plant origin, is organic. Those are of mineral origin, is inorganic. Plant origin examples: acetic acid, formic acid. Then citric acid, if you want, citric acid. Formulae are very difficult to write. Formic acid, oleic acid, several other acids are there. The inorganic acids, mineral origin, hydrochloric, sulfuric, nitric. There are many other acids. Phosphoric acid is there. Silicic acid is there. Many other acids are there. It's a mineral origin. This is the first division of acids. Okay, two types: organic, inorganic. Now, the second type of acids acids are sometimes called monobasic acids. Monobasic acids. Sometimes they are called dibasic acids, tribasic acids, and so on. Monobasic, dibasic, and then there is tribasic. This is depending upon the basicity of the acid. This is depending on the basicity of the acid. Basicity of the acid. Now, first you must learn what is basicity. Then only you will understand what is monobasic, what is acid. Basicity of an acid is the number of hydronium ions or hydrogen ions, either H plus ions or SO plus ions. Say, the number of hydrogen or hydronium ions a molecule of the acid can give. One molecule of the acid can give. One molecule. From one molecule of acid, how many replaceable hydrogen or hydronium ions can come out? Now look at this acid, hydrochloric acid. Look at this acid, hydrochloric acid. It has only one hydrogen atom, and it will give rise to only one hydronium ion when dissolved in water. The reaction would be HCl plus H2O. It will give H3O plus Cl minus. This is the reaction. When dissolved in water, a molecule of hydrochloric acid will give rise to one hydronium ion and a chloride ion. So it can give rise to only one hydronium ion from one molecule of the acid. Such an acid we call monobasic acid. And we say its basicity is 1. VA basicity. Its basicity is 1. The basicity of an acid is 1 if it when dissolved in water gives only one hydronium ion per molecule. The basicity of an acid is 1 if when the acid is dissolved in water, it gives only one hydronium ion per molecule. Write on your book. If one molecule of an acid, when dissolved in water, gives only one hydronium ion, its basicity is 1. The basicity of the acid is 1. We call that acid monobasic acid. Please write down your notebook. Basicity of an acid is the number of hydronium ions it can produce when one molecule of the acid is dissolved in water. Basicity of an acid is the number of hydronium ions one molecule of the acid can produce when dissolved in water. Basicity of an acid is the number of hydronium ions one molecule of the acid can produce when dissolved in water. You get it? So we see now the basicity of hydrochloric acid is 1. Because one molecule of hydrochloric acid can produce only one H3O plus, one hydronium ion. Basicity of sulfuric acid, H2SO4, is how much? 2. Basicity of sulfuric acid is 2 because it can produce 2 hydronium ions per molecule of the acid. Per molecule of the acid, it can produce 2 hydronium ions. See, look at this. H2SO4. H2SO4, when dissolved in water, it will first give HSO4 plus H. One hydrogen H plus. H plus HSO4 minus. That's how it will be written. H2SO4, and this arrow also is shown both ways like this. That means the reaction can take place both ways. So H2SO4 gives HSO4 plus H. So the first hydrogen ion it can give out like this. Again, this HSO4 can give out SO4 2 minus plus H plus. So in a molecule of sulfuric acid can give two hydrogen ions. A molecule of sulfuric acid can give two hydrogen ions. And therefore, the basicity of sulfuric acid is 2. Basicity of sulfuric acid is 2 because one molecule of sulfuric acid can give two hydrogen ions. Both these together can be written in one equation. You can write these two together in one equation. How? The two can be combined. These two equations can be combined, and you can see this HSO4 is common in both. So you can write H2SO4 when dissolved in water will give 2H plus SO4 minus 2 minus. Can be written in this way. So you understand here, one molecule of sulfuric acid giving two hydrogen ions. So an acid which can give two hydrogen ions per molecule is called a dibasic acid. It is called a dibasic acid. Its basicity is 2. Sulfuric acid basicity of sulfuric acid is 2. Basicity of sulfuric acid is 2. I hope you understood this. I have added up all these equations. In the equations, common things can be cancelled. Left hand side and the right hand side. Let's put a cancel. So H2SO4 gives SO4 2 minus and 2H plus. 2H plus. That is 2 hydrogen ions. So if an acid, one molecule of an acid, when dissolved in water, gives 2 hydrogen ions, then that acid is called a dibasic acid. Its basicity is 2. I hope you. Now there are tribasic acids also. There are also. Please copy it down. I give you time for that. Please copy it down. H2SO4, HSO4 plus H. Actually HSO4 is HSO4 minus is SO2, SO4 2 minus plus H plus. The two adding together, HSO4, HSO4 cancel. You get H2SO4 gives 2H plus SO4 2 minus. Since it is giving 2 hydrogen ions per molecule, it is called a dibasic acid. So basicity of sulfuric acid, basicity of H2SO4 is 2. Basicity of hydrochloric acid is 1, you have learned. Now basicity of sulfuric acid is 2. Please note down. You got it? I'll retain it for some time. We'll take another acid. Look at this acid, H3PO4. This acid is not known to you so much. This is called phosphoric acid. Phosphoric acid. H3PO4 is phosphoric acid. Now, without much explanation, I can tell you this acid is called a tribasic acid. It is a tribasic acid because it can give 3 hydrogen ions when dissolved in solution. 3 hydrogen ions it can give when dissolved in water. This is done in 3 steps normally. At present, you just understand it is tribasic because it has it can give 3 hydrogen ions when dissolved in solution. Another acid called silicic acid, which can give 4 hydrogen ions when dissolved in solution. Its basicity is 4. So acids are divided into classes based on their basicity. I am repeating what I said. Acids are divided into classes based on their basicity. Basicity of an acid is the number of hydrogen ions one molecule of the acid can give when dissolved in water. Basicity of an acid is a number showing how many hydrogen ions or hydronium ions one molecule of the acid. You get it? Basicity of hydrochloric acid is 1 because it can one molecule of hydrochloric acid can give only 1 hydrogen ion when dissolved in water. Basicity of sulfuric acid is 2 because one molecule of sulfuric acid when dissolved in water it can give 2 hydronium ions. 2 hydronium ions. Basicity of phosphoric acid is 3 SaPO4 because one molecule of phosphoric acid when dissolved in water can give 3 hydrogen ions. One molecule of phosphoric acid when dissolved in water can give rise to 3 hydrogen ions. So its basicity is 3. Have you understood? So acids are divided into classes. First I told you according to the origin of the acid, organic and inorganic. Second, I told you they are divided into classes based on their basicity. And I told you what is basicity. Write down if you are not written still. Basicity is the number of replaceable hydrogen ions that can be produced by one molecule of that acid when dissolved in water. That can be produced by one molecule of that acid when dissolved in water. That is basicity. Is it coming? An acid is said to be monobasic because if acid is said to be monobasic when its basicity is 1. It is said to be dibasic when its basicity is 2. It is tribasic when its basicity is 3. So this is the second class. Now another classification also is there. Another classification of acids is based on the elements present in the acid. Another classification is based on the elements present in it. Especially the element oxygen, if it is present in the acid. If oxygen is present, now hydrochloric acid, there is no oxygen, you can see. There is no oxygen in hydrochloric acid. HCl doesn't contain it. Sulfuric acid, it contains oxygen. H2SO4, this contains oxygen. Nitric acid, it contains oxygen. HNO3. There is hydrocyanic acid, HCl. Hydrocyanic acid doesn't contain oxygen. hydrocyanic acid. Another H2S is also an acid. It doesn't contain oxygen. So these do not contain oxygen. H2SO4, HNO3, H2CO3. H2CO3 is called carbonic acid. This is carbonic acid. H2CO3 is carbonic acid. This is a mineral acid. There is oxygen. Now, organic acids like CH3, COOH also contain oxygen. So all acids which contain oxygen are called oxyacids. All acids which all acids contain hydrogen, there is no doubt. Otherwise, it's not an acid. If there is no hydrogen, it is not an acid. But all acids do not contain oxygen. The acids which contain oxygen, they are called oxyacids. Oxyacids. And acids which do not contain oxygen, these HCl, HCl, H2S, these are called hydracids. Hydracids. So oxyacids and hydracids. Two types of acids based on whether there is oxygen in the acid in every molecule of the acid. Oxyacids and hydracids. Okay. This is all what I wanted to cover in today's lesson. This is all what I wanted to cover in today's lesson. Number one, water acids. Let us recapitulate. What are acids? Acids are substantial compounds which contain replaceable hydrogen and which, when dissolved in water, give rise to hydronium ions or hydrogen ions as the only positive ion. That's the definition of acid. Acids, I told you, are many types. Firstly, according to the source of the acid, acids are divided into mineral acids and organic acids. Organic acids, I give you example: acetic acid, formic acid, etc. Mineral acids, hydrochloric acid, sulfuric acid. And then again, there are oxyacids and hydroacids. When acid contains oxygen, it is an oxyacid. Acid doesn't contain oxygen, it's a hydroacid. I give you an example. Hydrochloric acid is a hydroacid, whereas HNO3 nitric acid is an oxyacid. So these are different classification. One more is based on basicity. Basicity of an acid is the number of hydrogen ions available from the acid, from one molecule of the acid when dissolved in water. Number of hydrogen ions available from one molecule of the acid when dissolved in water. If it's only one hydrogen ion, it is called monobasic. If two hydrogen ions can come from an acid, it is dibasic. Three, tribasic. Hydrochloric acid is a monobasic acid. Hydrochloric acid is a monobasic acid. Sulfuric acid is a dibasic acid. Phosphoric acid is a tribasic. So these are the different types of acids. This is the first class. I would like to give you some small homework today based on this class. The homework today what I wanted to give was number one. Please write down number one. Name two dibasic acids. Two dibasic acids. B. Two monobasic acids. 3. Two tribasic acids. Question 2. Name A. two organic acids, B, two mineral acids. Question 3. Name two oxy acids. Two oxy acids. B, two hydracids. Two hydracids. I'll tell you. If you cannot see the board, I'll tell you also. Question 1. Name two dibasic acids, two monobasic acids, two tribasic acids. Question 2. Name two organic acids, two mineral acids. Question 3. Name two oxy acids and two hydracids. Fourth question. Show through equations how hydrogen ions come from hydrochloric acid and sulfuric acid. That's all. Show through equations how hydrogen ions come from hydrochloric acid and sulfuric acid. This was the simple questions. Do them as homework. Okay. Enjoy your studies. See you in the next class. We will continue with the acids. Thank you. Bye.